Hi, I'm Mr. Chu, and this is my study room. You are welcome. If today is your first time, I want to encourage you to subscribe to this channel for more videos. For the past few days, we have been on circle theorem. So today we are solving WASSCE 2019 for private candidate, question 43. Please enjoy the lesson. Thank you. The question shows a circle MNRP, and we have been asked to find the value of in the diagram below. Taking theorem 2, which is a video just before this one, you will see that there are two chords which subtends two angles in each of the segments depending on the chord you are using, and both of them can help us get our answer. So I'm going to use both of them, and these chords are chord RP and then chord MN. Chord RP subtends angles at M and then N, and chord MN subtends angles at R and then P. And from what we did in theorem 2, it shows that this angle at R here will be the same as Y, and also the angle at N here will be the same as 35, which is the angle subtended at M. And like I said, I'm going to use both of them to show that we can use any of them to get the same answer. Now, let me take chord RP. Let me just join it so that everyone will see it well. Like I said, chord RP subtends angle 35 degrees at M. So since the same chord is subtending an angle at N, it means that here will also be 35 degrees. Good. And it is very important to state that with circle theorem, we must know other angle properties of polygons to help us to solve. So let me assume that the intersection of chord Rn and MP is Q. Let me just put Q there. And remember that this one is not drawn to scale. So since they didn't tell us that the intersection is the center of the circle, we don't assume that it is the center of the circle, because immediately we assume it's the center of the circle, there are other theorems that have something to do with the center of the circle. So we don't assume, they just intersect. It doesn't necessarily mean that they intersect at the center of the circle. So taking triangle MQR, we know that the sum of interior angles of a triangle is 180 degrees. And they've given us here that here is a right angle, which is 90 degrees. And we know that this 90 degrees and this 90 degrees are vertically opposite angles. So it means that here will also be 90 degrees, because there are two straight lines intersecting. And when two straight lines intersect, the angles opposite each other are vertically opposite angles. So since here is 90 degrees, here will also be 90 degrees. So we just have to add this angle, and y to give us 180. So that is what we are going to do now. Angle PQN plus angle QNP plus angle NPQ should give us 180 degrees. And this is because sum of interior angles of a triangle is 180 degrees. So now we know that angle PQN is 90 degrees. 90 plus angle QNP is 35 degrees. Then plus angle NPQ is Y. Should give us 180 degrees. So we do the addition. So 90 that is 125. So 125 plus Y equals 180. So our angle Y will be equal to 180 minus 125, and that will be equal to, so we have 125 there, so 180 minus our answer, which will give us 55 degrees. So it means our Y here is 55 degrees. Let's use this code MN2 to see whether we are going to get the same thing. So let me clean this line here and now draw this code MN quickly. There we go. Alternatively, using code MN, let me quickly join it so that everybody can see it well. This cos subtends the angle Y, the same cos subtends another angle at R, which will be the same as Y according to theorem 2. So let me just put my Y here, Y degrees here. Again, we are using the same triangle MQR. Let us complete this statement well. Alternatively, using code MN angle MRQ equal to Y because of theorem 2. Yeah, from triangle MQR, we will see that angle RMQ plus angle MQR plus angle MRQ should give us 180 degrees. Angle RMQ is 35 degrees. So you write out 35 plus angle MQR. MQR from the diagram is 90 degrees. And then plus our angle MRQ, which is the angle we are looking for, should give us 180 degrees. So 35 plus 90 is 125 plus angle MRQ. That should give us 180 degrees. So angle MRQ will be equal to 180 degrees minus 125, which will give us 55 degrees. And like we said earlier, if here is 55 degrees, because this chord MN subtends this angle and the same chord subtends this angle, and we said that according to theorem 2 they are the same, it means that if here is 55 degrees, here also be 55 degrees. And because this question is an objective question, our answer is going to be C, which is 55 degrees. Thank you. So this is how we apply theorem 2 in solving questions. So when you see the question, you check and see whether there is a chord which subtends two or more angles in the same segment of the circle, then you trace it. If yes, it's very likely that you might need it in solving your question. So you have to quickly write the angles in it, because one or more of them will be given, and that will guide you to apply to your questions. And just like we did, you might even have more than one chord that is doing the same work. So yours is to look out for the one that will make the work easier for you. Like we did, some people might use the second chord which is at the top, but it also looks like it has turned the work upside down, which might confuse some people. So depending on which of them best works for you. But the most important thing is that in everything we are doing, you need to keep practicing regularly in order to be able to do, because the theorems are more than one, you see, and you might not remember all of them when you don't practice regularly. So I encourage you to practice it more in other questions that are not only limited to the questions I solve in my study room. Thank you, and I hope to see you again. Bye bye.